So now, like I said, what we want to do is we want to actually take this detail, right, that we have that's at 1,000,000 polygons. And of course, you can go way higher if you've got a computer in Blender, but in my computer, this computer here I'm on, can go way higher than that, but it is going to depend on your devices, right? So we kept it simpler, not to get too crazy with it, but to show you some good fundamentals for masking and sculpting. And what we want to do is we want to bake this into a normal map, right? Now, because we built this directly into multi-resolution, we could just bake from multi-resolution. But technically, if you have multiple objects, you can have a high-resolution object and then some low-resolution objects, and you can actually bake a normal map to those, right? You could do that. We've kind of wanted to simplify the process. It's a high school class, right? Want to make it as few steps as possible for you guys, right? So we just focused on getting a good base mesh built, getting it UV unwrapped, and then we did our sculpting pass that we could bake into normal maps. And remember, basically a normal map is just going to take the direction of these polygons, right? They're normal directions. And it's going to turn them into colors that will be either red, green, or blue, like X, Y, or Z, or a mixture thereof, right? You'll see sometimes it's going to be, like I said, like a teal or a magenta. It's going to kind of really try to take the normal direction and give it an actual direction using the Cartesian coordinate system, right? And it's not always going to be perfectly X, Y, Z. So it's just taking the normal directions of hundreds, thousands, or millions of polygons and turning them into colored pixels that your light can then interact with later on, like that detail is there, right? Light either illuminates it or not, doesn't illuminate it, illuminates it like it's at a certain angle. And that creates the illusion of detail that's usually, in most instances, quite convincing. This is a big part of why video games have looked pretty good since the PlayStation 3 era. PlayStation 4 era in particular, and the PlayStation 5 era is just kind of insane nuts. But, we've been normal mapping as a big part of our gaming stuff since PlayStation 3 era, Xbox 360 era, right? So how do we bake a normal map down? It's actually pretty easy and pretty straightforward. What I usually do is I'll just go to my shading window here, right? So I'll switch from sculpting to shading workspace, right? And you can see I've got that ship material on there. And actually at this point I don't need, remember your shading workspace kind of shows you your full shader network, right? And certain things are easier to do in the shading network for materials than they are other ways. And fortunately, Blender's shader network is pretty user-friendly. In this case, I don't need that UV map anymore, so you'll notice that you can actually click on these different nodes. And we've seen this a little bit on our last project. So I can click on the UVs right here, kind of that map one, and I can just hit delete, and you see how it actually gets rid of that UV distortion grid, right? Now, I want to prep this, and I usually go to my blue wrench for my modifier, and just so I have a proper comparison from the low resolution mesh to the high resolution mesh, I'll usually just go to the level viewport and tell this to be 0, and the sculpt viewport and tell that to be 0, but I will leave the render level here in our multi-resolution modifier at that max level. So that way it's going to bake kind of from the renderer, the highest level to all those polygons, and it's just kind of doing a comparison between the difference between the low res and the high res to extract that data. I've also found sometimes if you have this high, it can slow down the normal map baking process. It's one of those little things I found. But I usually just turn those down a little bit. But you do want to leave the render one up at the top, right, the max level you'd subdivide it to. Now, to bake a normal map down, we need an image node in your shader network, and it needs to be selected so that it knows that to bake into a texture. So remember, you can go to the Add menu here. Remember, this is all in the shading workspace, right? Shading workspace. I can go to the Add menu here, and you see in the Add menu there is texture, image texture. So remember when we actually added that UV grid, UV distortion grid as a texture through the normal material, kind of blue, red ball, magenta ball kind of thing on the texture paint UV editing windows? That's actually the node. So you can actually get that same node through your shader network. So let's go to the Add menu, Texture, Image Texture. And you see I can just kind of drag and drop this where I want to. And now there's an actual image texture node there. We want that selected, right? You see how you can click on it and it's kind of got the white border outline. That means it's selected, right? So So now what I need to do is I need to go back over to my properties menus, which remember is this kind of part of your menu here. It's where your blue wrench, your modifiers are at, all that stuff. And if I go up to almost the top, remember there's that one that looks like a kind of a briefcase, microwave kind of thing. It's right below your wrench screwdriver one. It's the second one down of these kind of gray buttons. If you click on that, this is kind of really going to let you pick your render engine. By default right now, it's set to Eevee. That is Blender's quite excellent real-time renderer. We're going to see it a lot more when we do texture painting next week. But to get the proper normal map baking tools, we need to use cycles. This is Blender's kind of full ray-traced offline renderer. That's not supposed to be real-time, although nowadays most renderers can render quite quickly and you can get interactive render views. We've seen that a little bit when we did rendering on our last project. We'll see a little bit later on before the end of this term. But I'm going to switch my render engine, right? It's just kind of right here. It says Eevee. I click on Eevee, and you see I could pick cycles. I can pick cycles. And now that I've picked cycles, you'll see there's a lot of options available down here, including one called Bake. So I open up the Bake menu down here, and you'll see there's an option, Bake from Multi-Res, which is our Multi-Res modifier. So I'm going to click that on, and you see the Bake type by default is set to normals. So this can kind of be a quick, fast way to get a pretty good normal map out of Blender, right? Just make sure your model's ready to go, modeled, UV and wrapped. Then you can do your sculpting pass, and then when you're ready, you can just kind of bake from the multi-resolution mesh itself. So with the image created, right, add texture, image texture, and it just drops this in. And you can left-click drag to move it wherever you want to. Just make sure it's selected so that it knows to bake. Then we go kind of up to, the little kind of microwave briefcase icon. It's the second one down. It's right below the wrench and screwdriver. Remember, tell that rendering engine not to be Eevee, but be cycles. And then you can scroll down to the Bake section, open up the Bake menu, click on Bake for Multi-Res, and it's already usually set by, to default normals. And then all you have to do is click on the Bake button itself, right? All you have to do is click on the Bake button itself. Have an active texture use make. Oh yeah, I have an active texture. There we go. Let's see, come Bake. What's going on there? Let me make sure that to actually create a new texture here, because it's kind of not wanting to do it. Let's go new. And I'm going to make sure this is 4096. Actually, I was being a bit of a dummy. You do kind of need to tell it what resolution normal map you want to bake out, right? So remember, you have to create your image texture, but you have to actually click on new to create a new image texture, right? Actually, I think I'm going to do 2048, just so we don't, just so you guys have a number that'll work, should work for yours. Remember, we do factors of 2, powers of 2, 1024, 1024, 2048, 2048, 4096, 4096. I'll call this ship normals. There we go. So you pick the resolution you want it to be at. 2048 should be fine for you guys. I obviously could do it higher on mine. I usually do it higher on mine at home, but we'll kind of keep it more respectable, not exploding a computer if you've got a lower-end device. You could, of course, make it a 32-bit floating point. That's going to make it a bigger file size, so we'll just kind of say, hey, this will be good enough, even though it won't be the best normal map ever if it's not 32-bit floating point. It will be a smaller file size. And I try to take into consideration that you guys are working on older computers and your personal devices, and those aren't exactly have huge horsepower. So we'll just kind of 2048, hit OK, and now properly we've actually got an image in the image node here. So I did kind of forget that step momentarily. And now with that properly created, remember that's when you click new, right? You create this, a button called new will be there. You click on it, and it pops up your ability to give it a resolution just like we did with our UV grids. Make sure it's selected, and bake. And now you see it actually bakes. Now, you won't see anything quite yet, so what you have to do is you can kind of go over to this part of your shading workspace, and you see right next to new here, there is that little icon that looks like a pyramid with a little ball and kind of a square. If I click on that, you'll see these are all of the images that we have available to us, right? There's that metal from the sculpting I tried to do earlier, to show you a little bit the other day. There's your UV one. But you'll see there is one called Ship Normals. And if I click on that, you will see all of that detail now is an actual texture. And you see how you've got some kind of magentas, some teals. It's basically taking those normal directions and turning them into colors relative to the actual Cartesian coordinate space system, right? X, Y, Z. But those aren't always lined up exactly with X, Y, Z, so that's why you'll get, like mixes of those colors. But you see how it's actually turned all that detail into a 2D texture. There's kind of that predominant purple. That's considered to be your neutral because this is a tangent space one. Tangent space works great, particularly for characters, creatures. Basically, anything that's usually going to move or deform, it's good to have a tangent space on. If it's an environmental piece that never moves, you can use object space or world space, depending on what your software calls it. The normal map quality isn't really better, but it kind of can be more rendering efficient for games and real-time stuff. So it's kind of like a trick where the normal map quality won't look better, but it can run in an engine more efficiently because its color coding works a bit different for it. But since this is a spaceship, and I do a lot of character creature stuff, I tend to just work with tangent-based maps. And that was the default, right? It's kind of the default there. So that should be good. That should work pretty well for us. So now we've got it made. We do want to make sure to save it, right? So if you go kind of from this kind of white triangle one, there's one that's like 3 white bars, right, that are horizontal. If I click on that, you'll see there's an area called image with an asterisk next to it. When you see an asterisk next to that in the image view, that basically means something has to be saved. So I have to go here to save, and it does have a default quick key, not Control S, which is our normal save. Alt S will save your textures. So I'll go to save, and I'm just going to call it Ship Normals PNG. If you want it to be a bit higher quality map, PNGs usually work pretty well. They're pretty good maps. They don't compress like a JPEG will. If you want your higher color depth, you can go 16. I'm going to say we're going to stick with an 8 just so that our file sizes are smaller. That will affect the quality somewhat, right? Not radically. They'll still work pretty well, but the higher the bit color depth, generally the higher the quality of the map. It has a smoother transition between colors. But also, the file size is bigger because it's more bits of information per channel, right? Red, green, blue, alpha. We'll just use the defaults because that'll be easier for you guys to remember, right? Save as image. And now that's been properly saved. And now all we really need to do is plug this onto the model, right? And in fact, just to fully show this, I'm going to go back to my blue wrench, and I'm going to get rid of my multi-resolution modifier now, right? Remember, it's still there. I've just turned it down to 0 for the level of viewport and sculpt. But if I go to the blue wrench, I can click on that X to get rid of that multi-res, and it's no longer there. There's no more sculpt detail. So this is going to all rely on that normal map. Now, in the shader tree, right, this is our core material that's on us, right? Ship, we kind of created those before. Remember, if you go to the red sphere, you can always create a new material, give it a name, and that's kind of the actual material that's on the object. Now, in this case, you'll see there's a lot of little kind of sliders here, just like they are here. In fact, this is the same information here as here. You just kind of see it as a little thing you can grab, right? And you see towards the bottom, there is a section called normal. So if I left-click drag on the color, that's a yellow dot here, if I left-click drag on that, it drags out a little kind of a white-yellow curve with a plus, and I could drag this down to the normal section. And you see how it changes color, whatever one it's going to plug into? So I plug it into normal. And now we have this color channel plugged into your normal channel. Now, I want to be able to control this a bit better, so I'm going to go to Add, Vector, Normal Map. And you'll notice that if you put this over one of those curves, it'll actually plug it in for you. There we go. And you can always tell it to use the UVs that are there. And you can actually control the strength. I'll zoom in here a little bit so you can see this. You can actually turn the strength up for your normal map. Now you notice how this shading is still looking weird? That is because generally, even though this is a map with color information, you don't really want it to use that color space because it's really working differently than a normal color map, right? It's just using that color information to control the shading. on the mesh, right? The kind of how the light interacts with the pixels. So what you do is you change your color space from sRGB to non-color. And then you see how it actually lines up and looks pretty good. But you notice that looks like all that detail that you did sculpting-wise, but it's actually on the mesh, and you see if you zoom in close enough, it's actually, your mesh is still flat, right? It's not actually pushing those in or pushing those up like it did sculpting. But you notice how most of the time, it's still quite convincing, right? And like I said, we can turn that strength up to make it more detailed or less. That's why I kind of like to have this normal map node in between them, so it gives me more controls. What's really cool is if you actually were to plug in an add vector bump node, you can actually plug this into normal and plug this normal map into that normal, and then you can plug a bump map into height, and you can actually have bump maps and normal maps working together. We're not doing that on this project, but you can actually, and I didn't know that for a while. I was like, man, I wish I could do that, and then I finally figured out how to do that in Blender, you know, because I'm newer. I've been learning it the last couple years. So you can actually have bump maps and normal maps plugged in together. We don't need to do it for this one. We're not doing that, but I figured I'd mention it. Some of you guys are a little more advanced. You might want to try to explore that, but if you kind of plug those node networks together properly, you can get bump maps and normal maps to work together. And bump maps and normal maps are actually cousins anyways. They're doing a pretty similar thing. It's just that a bump map primarily just uses the grayscale to make the polygons look raised or depressed. Normal map, since it's taking the normal direction, can get more nuance. Like if it's just a heavily image-based texture like a brick wall, a bump map and a normal map are indistinguishable. But if you're doing like sculpting on a character creature where you've got like muscle deformation, scars, wrinkles, a normal map's going to be like fabric folds. A normal map, because it's going to take the normal directions, it's not going to just be kind of binary, up, down. It's going to kind of take in all the normal directions, and so you can kind of get a more dynamic look. Those kinds of details look way better in a normal map, derived from sculpt data, than a bump map. A bump map you do not have to derive from sculpt data, you just paint it. Okay, and that is how to bake a normal map and how to kind of plug it together into your shader tree. And now that detail's there still, but it's now a texture that can work in games. The only other thing you want to remember is to go to File, External Data, Automatically Pack Resources. And what that'll do is you'll see it automatically packs all external files in the Blender file. So any textures, like this normal map that you've baked out and plugged in, any color maps you paint, these will automatically, when you save your Blender file, be saved in the Blender file. It's really, really awesome that Blender does this. So I'm going to save that, and there we go. And that's how that works. All right, stop there.